Then okay, for other
Hello.
ones, what's the color of the reaction?
Hello.
You can find that.
Yes, sir.
Yes, for extra. Okay, no, that let's start with this. Let's see
Let's feel it.
For this is that
Have you feel
I already know how the phone
Can anybody hear me? Can anybody hear me?
My ex is not sitting there.
Hello.
My wife is not
Jambo? Yes, you have to feel it. Oh, one. This is the only one they are feeling.
Let me test it. Test it. 1, 2, 3.
My church on.
I don't even know for this.
I'll swap your charger.
Hello, guys. Mute your mic now so that we can hear what the lecturer is
Please
saying.
mute your mic so Joe.
Guys,
You guys should mute your mic, I beg now.
guys, mute your mic. Nobody wants to mute their mic.
She's almost
I'm hearing the voice. Are you in the Zoom? Your voice, your voice. Hey, I'm talking here now.
And if this provider, listen, about 2,000 people fighting for the class, there will be a time that what should you do bad? You actually do that I know. Now what affected them with the best. Why am I going to for everyone?
So I also want to do that. If you're listening, just
Yeah, Daniel, can you hear me? Caleb. Caleb. Sarah, can you hear me? Sarah, can you hear me?
Yes, I can hear you.
Okay, David. David Folorusho, can you hear me? David. Daniel, Oloruntola, can you hear me?
Yes, sir.
Okay, thank you. Okay. Good evening, everyone. Good evening, everyone.
Good evening, sir.
Okay, thank you, Alabi. Okay.
Yes, sir.
Yeah, welcome to Chemistry 156. And more students are still coming. But from now, I'm going to start for the next 1 hour. This is the first class that we're having. And the course is divided into 6. The course is divided into 6 broad areas. The first part is you have here. This is the first one. The first part, atoms, molecules, and intermolecular forces. And that will be taught by one of the lecturers. And the second one is acids, bases, and salts. That will be taught by another lecturer. And then you still have oxidation and reduction, electrochemistry. Then you also have thermochemistry, spontaneous processes and equilibria, reactions like that. Then you have reaction kinetics. Then you have reaction kinetics. Okay, then you have kinetic theory of gases. Okay, so you have 6 lecturers that will teach this course. And this 5th one, reaction kinetics, that is what we are going to start with. My name is Nancy Okpako B. Egbedi. I've divided my lectures under reaction kinetics into units. And we are starting with unit 1. Okay. And so the topic under unit 1 is rate of reactions and factors that affect the rate of a reaction. So as I go along, I'm going to be repeating rate of reaction, velocity of reaction, speed of reaction. And anytime I'm talking about the rate of a reaction, speed of a reaction, velocity of a reaction, essentially, I'm talking about the same thing. So this topic is rate of reactions and factors that can affect the rate of reaction. But rate of reaction and also what you call the mechanism of reaction, they are under what another broad area you call kinetics of reaction. So as we go along, we are going to be hearing rate of reaction, speed of reaction, velocity of reaction, kinetics. So if I'm talking about kinetics, I'm talking about the rate of reaction. Rate is the same thing as speed of reaction, same thing as velocity of reaction. So they mean the same thing. There are also factors that affect them. So when we talk about the rate, then we look at the factors one after the other as we go along. But this particular topic, we'll be talking about the speed of reaction, velocity of reaction, rate of reaction, and some of the factors that do affect the rate of a chemical reaction. And so, as I said, this topic is rate of reaction. And it is with the mechanism of reaction. These two phrases or expressions, they fall under what you call the kinetics or reaction kinetics. So essentially, the study of reaction kinetics is concerned with measurement of the velocity or rate of reaction, together with factors that affect the rate of the reaction and the mechanism of the reaction. So when I talk about rate of reaction and mechanism of reaction, essentially we are discussing the kinetics of that particular reaction. So at this point, let me explain to you. The rate of a reaction is the speed of a reaction. Like, let us use you, for example. If you are traveling from here to Lagos, 100 kilometers, the distance is 100 kilometers. In chemistry, instead of calling it 100 kilometers, I will call it 100 mole per dm cube. 100 mole per dm cube. That is concentration. Then the time it takes you from here to Lagos, 60 minutes, is the same thing as the time for that particular reaction. So if we are talking of the kinetics of your journey from here to Lagos, we want to know the speed. The speed is the rate. 100 kilometers over 60 minutes will give us the velocity or the speed or the rate of your reaction. Then I will also want to look at the mechanism of the reaction. How did you travel to Lagos? Did you enter a taxi cab? At a point, did you use Okada? At a point, did you trek before you got to Lagos rather? Did you trek? How were you traveling? Was it through a very rough road with hold up? That's what we call go slow. If you sum all that together, it will give you the way you travel to Lagos. The way you travel to Lagos is what we call the mechanism of the reaction. So first, we can look at the speed of your reaction to of your movement to Lagos. That is 100 kilometers over 60 minutes. If it is chemistry, we will say 100 mole per dm cube over 60 minutes. That will give us the rate of your traveling. So your distance is like concentration. Your time is the normal time that we also use in chemistry. And then after looking at your speed, which is now the rate, we also look at the way you move. At a point, you took a cab. At a point, you trekked. At a point, there was a hold up. When we sum all this together, it will give us how you were moving to, how did you travel to Lagos? Did you use a very good car? Did you go through a lot of potholes? Did you go through? So when you are giving those details, you are giving a kind of account of how you travel to Lagos. That is a trivial example. Now, when we go to chemistry, we want to study a reaction. A reaction is like hydrogen plus oxygen, and that will give you H2O. If you want to study the speed of that particular reaction, you will be measuring the concentration of the reactants or the product. The reactants are hydrogen and oxygen. When they react, they come together, and that will give you H2O, which is water. So we can study the speed of that particular reaction, and then we'll be dealing with the concentration. In case of you traveling, we'll be dealing with distance, and we will be dealing with the concentration of the reacting species or the products, and also time. So you traveling, at a point, if daddy is driving, you will ask, at what speed, sir? At what speed, daddy? He will tell you 20 kilometers per hour. So while you look at distance, what we are going to look at today is concentration, how the concentration is changing, the time rate of change of concentration, and that will give you the velocity, that will give you the speed, that will give you the rate of the reaction. So anytime using those three phrases, essentially I'm talking about the rate of a chemical reaction. And so what are the factors? As we go along, we will look at the rate in detail. We will look at mechanism. The mechanism is the way, excuse me, is the way the reaction occurs, is the molecular events of what is happening, is the summation of all the steps. See, I was telling you, did you trek? Did you enter taxi cab? Did you run into hold up? It's the summation of the elementary steps, all the steps involved. The totality of that will form what we call the mechanism of the reaction. It's the way that you are explaining how the reactants are changing in their progression to product. So chemistry is about changes. You know, reactants will come together and that will give you product. How are the reactants changing to give you product? If you can tell that story, if you can give an account, you are giving a description of how the reaction is occurring, and that is the mechanism. And then you talk about the speed, and that is what you call the rate. So two things are standing out here. The two things, they fall under what we call the kinetics of the reaction. So take note of all that. And as we go along, we are going to be dealing with each of them so that you can get a better understanding of what is going on. Look at that. The rate of a reaction describes how fast the reaction goes. How fast? How were you traveling? Did you travel 100 kilometers per 2 minutes in your journey to Lagos? It's not very possible. If you can do it 2 minutes to get to Lagos, and somebody can do it 1 minute to get to Lagos, the one that uses 1 minute is faster than the one that's using 2 minutes. So the rate of a reaction describes how fast the reaction goes. And explanation of how a reaction is occurring. Look at that. Explanation of how the reaction is occurring. And that will give you the story, what you call the mechanism of that particular reaction. And there are factors. So we're going to be looking at factors that can affect it. Again, let me take you back to a very trivial example. Your journey to Lagos, it can become like a kinetic reaction that can study. How can you travel very fast if you want to go to Lagos? You need a good road, you need a good car, you need a good driver. So all those ones will affect your speed to Lagos. If I give you a good road, a good driver, and the car is not good, you are not going to be very fast. So the car now becomes a factor. If I give you a very good car, I give you a good driver, okay, and there is no fuel to power the car, you can't get to Lagos. You see how, if I give you all a very, very good car of your dream, and you have a bad driver who is a learner, it will affect it. So if they ask you, what can affect your speed to Lagos? You will say The driver, is it a good driver? Is it a good car? Is it a good road? Availability of the gas you are going to use, which is petrol. And also, maybe when there's no hold up, your journey will be faster. That is a trivial example. That is not the chemistry. Now, we're going to take it into chemistry. What are the factors? So as we go along, we're going to be picking the factors and we look at each of them in details. Essentially, that is what this aspect of the course is all about. And then as we go along, this is take note, prepare. I'm going to give you 2 quizzes. So I'm going to test you, then 2 quizzes and 1 test. So be preparing for my test. By the grace of God, by next week, you will be writing quizzes and tests. So prepare for that. All that I'm teaching you, just read them. Whatever I'm going to teach you this evening is already on the platform. So you can go there and download and then read again so that you can understand better. Okay, now let's go on. In this particular unit 1, this is how you can understand faster. In this particular unit 1, see some of the key concepts from what I have been saying. I'll be talking about, you should be able to look velocity. I'll be talking about velocities most of the time. I'll be talking about speed. I told you that essentially they are the same. I'll be talking about reaction rate. I'm saying the same thing too. I'll be talking about reactant. I'll talk about product. Look at what I mean. This is A. If A is a reactant and it's reacting with B, is it appearing on the screen? Okay. And reacting with B, A and B are reactants. Look at that. There is an arrow. They taught you this in school those days. The arrow is pointing to it will give something. And what is it? It will give C. So A is a reactant, B is a reactant, and C is a product. So we're going to be talking about reactants like hydrogen. What is the example of A? And that is hydrogen molecule reacting with, what does it react with? Oxygen. So what will it give to you? It will give you H2O. So hydrogen and oxygen are reactants. H2O is a product. So we're going to be talking about reactants. I talked about products. I told you chemistry is about changes. Can change from one form to another. And that is why I'm going to be studying so many things: energy involved, reactant, product, and some other factors. We're going to be talking about the initial rate of reaction. We talk about determining step or limiting steps. And so these are some of the key points that you will come across under this particular unit 1. Now let's go. What are the objectives? I have not started teaching you, but I'm just preparing you for what I'm going to teach you in detail. In this unit, you will learn more about factors that affect the rate of reaction or speed. And you will explain how a reaction is taking place. That's what I mean by mechanism. In this unit, you will understand that some reactions are very fast, and some of them can take weeks, some of them can take years, and some, as soon as you mix them together, the reaction is all over. So, and that is one of the reasons why we have to study the speed of a reaction, so that you won't be putting things together that can easily explode. And that is why I have to be very careful. So it's very important we know reactions that are very fast, reactions that are very slow. For example, if you go home, what do you use to cook at home? You use gas, like butane gas or propane, that you bottle them. You turn them into liquid, bottle them in gas cylinders. That's what you use in cooking at home. Why do you use that? Why not you put water in that gas cylinder? It will not work. It is because the hydrocarbons, propane, butane, they burn faster and they give a lot of energy. But if you put water there, it is very slow. It will not burn. And that is why you are using those hydrocarbons to cook. So it is very important for us to study the rate of reactions. And as we go forward, you will see more reasons why we have to do that. So that is some of the objectives why you are receiving these lectures under this particular unit 1. Now let's go. Okay, you can go ahead. Why do you have to, heat your egg? You boil it before you eat it. Why? Why is it necessary to do that? It is because some chemical reactions will occur. So it's necessary for you to add heat to it in order to cook it properly. The length of time required for a particular reaction to occur also depends on factors. It depends on the reactant. And all this will prepare you to find out, why do you study the speed of chemical reactions? Do you eat your food raw? Yam, you just start eating it? No, you have to cook it. Why do you do that? Because you want some chemical reactions to take place. I'm preparing you to study, why do you need to study the rate of chemical reaction. So what is the expected outcome? After you've received all these lectures, what are you expected to know? What can you explain to your classmate that this is what I gained from this particular unit 1? At the end of the lectures, if everything goes well today, you should be able to define and explain the rate or velocity and mechanism of a reaction. What is I have explained it all along. What is the rate of a reaction? I'm going to define it is the time rate of change of concentration. Is the concentration, the change of concentration per unit time. And essentially that is the rate, that is the velocity. And the mechanism of a reaction is the way the reaction is occurring. Is the explanation of the molecular event that is happening to the reactant in their progression to product, or the summation of all the factors, all of the elementary steps, the totality of all the steps, you add it together, it will sum up what do you mean by the rate of a chemical reaction. So it's very important to study the rate of a chemical reaction. What you are familiar with from school, if hydrogen is reacting with oxygen, or to give water, H2O, or nitrogen is reacting with hydrogen to give ammonia, all you know is the outcome of the reaction, or what we call the stoichiometry of the reaction. And those are some of the things we were studying in school. Carbon plus oxygen, that will give carbon 4 oxide. So you balance the chemical equation, and I would say that is the stoichiometry of the reaction. Beyond that, and sometimes it is very important to also study the speed, in addition to the stoichiometry of the reaction that you are familiar with from schools. And it's very important to study the rate, the speed of reaction, and also the thermochemistry of reaction. And so this is how I have prepared you to know what you mean by the rate of a reaction. In a short while, we're going to define it, and then you will understand it better. And expected outcome, you should be able to list the factors that affect the rate of reaction. I've done that for you in your journey to Lagos. A good car, a good road, a good driver, all that will help you to get to Lagos very fast. If I give you one of the best cars, and I give you a very good driver, the road is to Lagos, no more repairs. The road is very smooth and there's no hold up. You will get to Lagos within 1 hour. You know that. You see how those factors affected you to get to Lagos very fast. Very fast. That is a trivial example. So in chemistry, what are the factors that can affect the speed of a reaction? So let's go on. I've told you what I mean by reaction kinetics. Reaction kinetics, and that is under this reaction kinetics, you study the speed of reaction and the mechanism of reaction. And I've been explaining all along for about 20 minutes now. What do you understand by the rate? What do you understand by the mechanism? In a short while, you will see it in form of expression. Okay. So these are some of the things I'll be talking about. That it's not enough to understand the stoichiometry of reaction. Most of the things we were studying in school is how to balance chemical reactions and talk about, how reactants come together to how many of the moles, and then the mole concept, how many moles of the reactants A and B or whatever is reacting to form product. Okay, so it's not enough to study that. All you need is to write the equation and you see the way it is. And the equation is more complicated like more than what you see. Hydrogen reacting with oxygen is not as simple as that to give H2O. And so it's not enough to look at the stoichiometry, but you can study the rate of the reaction and also understand how these factors, what are the factors? In a short while, I'm going to tell you all the factors govern the speed of a reaction. How does a good driver govern your speed to Lagos? How does a good road affect the speed to Lagos? That's what we're talking about. And I've already given to you what do you mean by chemical kinetics and how it is with the rate of a reaction and the mechanism. So essentially, if I want to define chemical kinetics, I will say it answers the question, how fast does a reaction go? And what is the mechanism of that reaction? Chemical kinetics or reaction kinetics will answer the question, how fast? How fast means rate, speed, velocity. So the chemical kinetics is broad, so it covers that area. How fast does a reaction go? And what is the mechanism of that reaction? What is the molecular event of that reaction? Can you describe how that reaction is occurring? And so it deals with the speed as well as the mechanism of that reaction. So let's go. I'm still asking you questions, preparing you to understand all the concepts that are involved. All the concepts that are involved. The study of rates of chemical reaction is called kinetics. It's the same thing. And I'm trying to answer the question again. If you want to deal with how fast does a reaction go? That is the rate. And what is the mechanism of that reaction? That is the molecular event or the way the reaction is occurring. Therefore, the very simple way, they ask you what is the rate. At what rate do you spend your money? That's a trivial example. I'm just encouraging you to understand. You can ask yourself, rate is the number of events per unit time. This is a very simple way of defining it. Rate, number of events per unit time. And that is why concentration per unit time. And that will give you the rate. So everything should be very clear to you now. All the terms that I'm going to use. And what is the purpose? The purpose, again, we will look at it below. Why do you measure the rate of chemical reactions? Why? If you have been following me, I have talked so much about why you should study the rate of a chemical reaction. They ask you some of the reasons. So how fast a chemical product will work. And some of you on television, they will say, take paracetamol, drink it with, take it with water, and within 30 seconds, the man will be, from body movement, language, it's as if the headache is no more there. So if it takes 10 seconds for the headache to disappear, it means that particular paracetamol is working very well. But if it takes 2 hours to disappear, then it's not working very well. And then that will give you an idea that it's good. When you use some product, you say, oh, for 2 days now, I cannot see the effect. But you use some product for a particular thing. Within 1 hour, you say, I can see the effect. This thing that has been disturbing me is going away. And so how fast a chemical product can work is very important. If you want to produce it, then that aspect is very, very important. And then, of course, you need to, that will give you an idea of the speed of the working of that particular product. Look at that. How quickly and economically. They taught you in school when we were producing ammonia. He said, increase the pressure, increase the, decrease the temperature. You manipulate the factors and you get more ammonia. If you remember Haber process, that they taught you in school those days. I want to get more ammonia. Ammonia is needed, and so that I can sell and get more money. So how do I get more money? Economically, if I manipulate the factors that can give me more ammonia, I will get more ammonia. And I will spend a little amount of money. And that's what I mean. How quickly and economically a product can be made. How do you get to know that? So that you can maximize your profit. So it's very important how quickly and economically a product can be formed. And then get a knowledge of the reaction mechanism. Look at that. Look at this point. A knowledge of the reaction mechanism. That is how the reaction is occurring. If you know it, then you can create alternative. If I ask you to go to, maybe all of you are not on campus now, but if I ask you to go to our hall and you have to come through, then you have to come through, go to our hall. Instead of going to our hall from the Faculty of Science, CBN, and then you now begin to go to postgraduate school, Faculty of Pharmacy, before you start going to our hall. And then that will give you a problem. You will not get to our hall on time. So a knowledge of the mechanism will help industrial chemists, somebody who has a factory that is producing ammonia, a knowledge of the reaction mechanism, how ammonia is produced. If I know a shortcut, I can produce more of it. And that will be very important. And therefore, I need to know the mechanism of the reaction. And once I do that, and then I will get more of the ammonia. It's the same thing as a drug. A pharmacist will also find out that what will it do to a particular drug by modifying it, producing another one that has more power, efficacy, the drug, by modifying the structure of existing drug, you can make it more efficacious, and then it will cure the sickness faster. And that is why you have, if you look at the history of Nivaquine, Camoquine, Chloroquine, and then you will find out what they were doing to the base, to the structure, to make it more effective, so it can cure malaria faster. And so we need to know all those things to help us. So that is why you also study the rate of a chemical reaction. And more importantly, chemistry, we know chemistry, I told you at the beginning, has to do with changes, transformation. And so we need to learn a great deal about how reactants change into product. The molecular event, how many moles are consumed to give, what is it going to give? We need to know that. So we study reactions very well. After getting the speed, we move ahead and know the mechanism of reaction. At this point where I am now, you can explain what is rate of reaction. You can explain what is mechanism of a reaction. And then let's go to the factors that can affect the rate of a chemical reaction. Already I told you the factors that can affect your speed to Lagos. What about the chemical reaction? You're traveling to Lagos, it's not a chemical problem that I want to solve. If I take a chemical reaction, I'm looking at it. And these are some of the factors that can affect the rate of a chemical reaction. Look at that. The first one, ability of the reactants to come in contact with each other. It can affect the rate of a chemical reaction. Look at, if A will react with B, what is A and B in a short while, or the next class I will tell you, to give a product, A must come in contact with B. So ability, if A has no ability to come in contact with C, they must, with B rather, they must collide. They must come together to form the product, which is maybe C, okay? To form C. C is the product. A and B are the reactants. If A and B cannot come together, you can't form C. And if they come together in a good way, and that is, we are going to tell you how they come together after some time as we continue to receive lectures. They will collide and then form product C. If they have difficulties in getting in touch with each other, you are not going to form C. And so that purpose of forming C is defeated. And so ability of the reactant to come together or to come in contact with each other is one of the factors. Concentration, I know that they must have taught you this in school those days, where you're coming from, SS3 and so. Concentration of the reactant, it increases, when you increase the concentration, if I increase the concentration of A and I increase the concentration of B, if everything goes well, I'm going to form more C. So that's how it goes. So concentration does affect. Concentration does affect, or concentrations of the reactant, they do affect the rate of chemical reactions. And it's the same thing with you. If I give you 2,000 naira to go and spend, it's a trivial example. I'm just helping you to understand what I'm presenting. If I give you 2,000 naira to spend, to go and buy things, you will buy one or two things. But if I give you 200,000, it's very likely you will not come to school tomorrow. You will start spending and spending to buy more things. So it's the same thing. If you increase the concentrations of the reactants, if everything goes well, when I mean everything goes well, you will find as we go along, other factors are okay, you're likely, and that is the truth, to form more of the product. And more importantly too, you have temperature. If you increase the temperature of the reaction system, and of course, you increase the temperature, increase the energy of the reactant, they move faster with higher velocity, they collide. And if they need to collide to form more product, the more collisions, the truth is that the more products you are going to form. The temperature will give the reactant more speed, more energy. Then they move faster, travel faster, collide, and everything goes well. And then you're going to form more of the products. So these are some, and last, another factor that I have, which they have taught you in school. I know you must have heard of catalyst before. You can add a catalyst, a substance, an agent called a catalyst. You add it to the reaction system. And if you add the appropriate catalyst to that particular reaction, you're going to form more of the product. And that is why when they taught you about Haber process, the formation of ammonia, they use a catalyst, or contact process in the formation of sulfuric acid, sulfuric 6 acid. There was a catalyst there, so that you can form more of the product. I'm just using what they taught you from schools so that you can understand faster. Now, look at what I started with at the beginning. I said at the end of this unit 1, you should be able to understand and explain what you mean by the rate of a reaction. If they ask you what is the rate, you say it's the time rate change of concentration. What is mechanism? Is how the reaction is occurring, or description of how the reaction occurs, or the molecular event that is taking place. See, that is very clear. Okay, what are the factors that affect the rate of a reaction? Name 2 or 3 of them: temperature, catalyst, concentration, ability of the reactant, or some of you in your schools, they must have taught you the nature of the reactants. Are they in form of blocks, pellets, or in form of powder? If the reactants are in form of pellets, okay, solid, it's more difficult for them to react. But if you grant the reactant, they are in form of powder, you now increase the surface area of the reactants, and then they react more. And that's what you mean by the nature of the reactant. And so you can add that to the factors that can affect the rate of reaction. The nature of the reactant, are they in form of powder or in form of solid? Solids are more difficult to react, but in powder form, okay, you create more surface areas for them to react, and they react faster. So you can name, I have named about 4 now, 5. You can name 2 or 3. When I give you a question, this OPJ, I can say, name one of the factors that does affect the rate of reaction. They can put water there. They can put vegetable oil. They can put car, and they can put temperature. Which one will you pick? Which one will you pick? So let's go forward. So I have talked about this, the rate of velocity or speed of a reaction can be determined for a particular reaction. But this speed affected by factors. I have listed the factors. I have talked to you about the mechanism of a reaction. Again, let me add more to the mechanism of a reaction. Whichever one you can remember, there are so many ways I've been describing it. The mechanism of a reaction, that's what I mean by describing how you travel to Lagos. Can you not describe it to somebody who did not go to Lagos with you? That is how you traveled. That is what you call the mechanism of your journey. That explanation. When we go to Redeem Camp, they stop the car. We have to come down. We have to trek like 1 kilometers. Then I took Okada. Then I took this to Ojota. If you can give account of all that, that is what you can refer to as the mechanism of your journey. And so in a chemical reaction in chemistry, we can say the mode by which is the way by which you transform. I told you in chemistry, it deals with transformation of reactant to product. The mode, in what way by which a reactant or reactants is transformed or are transformed into a product is the same thing of the mechanism. I can define it in another way. A collection, look at this, a collection of individual kinetic processes. What I mean by processes is like a product. When you bring out a product passes through so many stages. All those stages, each of them is a process. How did you get to the university here? You went to primary school, you wrote JAMB. You went to secondary school, you wrote JAMB. You came for post-JAMB, you were on all that. Now you're in the university. How did you get here? If you want to look at the mechanism of how you got admission into the University of Ibadan, you give account. I went through primary school, secondary school, I wrote JAMB. I came for post-JAMB. Finally, I'm here. We thank God. When you give account of that, that's what you call. So each step, secondary school, primary school is the process. Primary school is elementary step. Secondary school is a process. Secondary school is elementary step. So I'm just telling you, elementary step is like a process too. JAMB is a process. It's elementary step. Also add everything together. What is the outcome? Admission into University of Ibadan. And that is the product. So when you add up all the steps, when you're doing that, it's the same thing as mechanism. Now let's take another step, another explanation. In fact, there are so many of them to explain mechanism. You will get all the marks. Okay. Or I have explained that it's a molecular event. What do you mean by molecular event? It's how the reactants are taking place. They will react together. They can form some other species, which we call temporary dialogue, like temporary species, okay, that will react again. And then, so you have to sum up all the processes that are involved. After some time, you see a particular example that will explain that to you. Or a series of individual steps. All the steps you take leading to the overall chemical reaction. Hydrogen plus oxygen, and that will give you H2O. The overall reaction is the stoichiometry of that particular reaction. And so when you add up all the steps, it will give you the stoichiometry. And that is what you have been studying right from school. Balance the equation, carbon plus oxygen, carbon 4 oxide, nitrogen plus hydrogen, ammonia. Balance it. Those are just stoichiometric balanced chemical equations. But what happened? How did you get ammonia? How did hydrogen react? How did it react with nitrogen to give you ammonia? All that, if you can give account, and that's what we call the mechanism. So it goes on and on. Let me give you a particular example. Look at this. In school, they will tell you this is dinitrogen pentoxide. We decompose if you heat it, if you apply heat to it at a very high temperature, it decomposes and it gives you nitrogen 4 oxide and oxygen. Nitrogen 4 oxide and oxygen, those are the products. The nitrogen pentoxide, that is the reactant. And so the reactant can decompose to give you the product. What you see on the screen now, that's what we call a balanced chemical equation. And that is the stoichiometry. But chemistry is beyond that. As you go along, you will study the rate of such a reaction. You will study the thermochemistry, you will study the thermodynamics and stuff like that. Other lecturer will teach you all those things. Those are stories for some other lecturers, and they are coming. So I'm going to use this one to give you an example. If I want to get I want to study the kinetics of this reaction, I will find the speed of this reaction. After finding the speed, which is the rate of the reaction, sometime next week, I will teach you how to find the speed of a reaction. After finding the speed, I will now give account of how I was able to form, how the reaction was able to come out with nitrogen 4 oxide and oxygen. I must give account. If I can't give account, they won't believe me that I just apply heat to the nitrogen pentoxide and I got nitrogen 4 oxide and oxygen. So you can give account. The account you are going to give, if you and your friend, you travel to Lagos in different cars and arrive in Lagos at different times, you all got to Lagos. But the account two of you are going to give how you got to Lagos, it's not going to be the same thing. But what is the ultimate? Is to get to Lagos. You're already in Lagos, two of you. So each person will give his own account. But the account must be accurate, must agree that you people got to Lagos. So this particular reaction you are seeing on the screen now, I'm going to use my own way to explain. And as I'm doing that, I'm giving you what you call the mechanism of a reaction. I'm giving you the molecular events that be able to summarize what happened to the reaction in the way the reactants were coming together to give you product. For example, look at that. I have it. Is it clear on the screen? Look at your screen. Look at what I'm going to give. I said I name it. This is my own way. Okay, this is my own way. So I just name it one way. You can have your own way. If you what is the name on the screen now? Let me say any name there. Okay, okay. What? Okay, let me say John. John, you can. Okay, Toby on the screen there. Okay, this is my own way. So Toby can also give account of his own way. But the account two of us will give, we come out to give something like this. It will come out to give what is below. This is what you'll be studying in school. All that you have been doing in school. Look at that below. And that's what we call the stoichiometry. But how did you form nitrogen 4 oxide and oxygen? This is my own way. Toby can give his own way. Look at that. This compound will decompose. This is a reactant. It decomposes in a very slow step. You know, in your journey to Lagos, you enter a car from Ibadan to Ojota. And when you go to Lagos, you want to take a Okada to your house. Which one is faster? So some steps are slow. Some of them are very fast. So I'm going to give the account here is my own. As you study chemistry, you become wiser. With experience, you can give your own account. But finally, two of us, or three of us, or anybody who's giving an account must end up with the stoichiometry, the balanced chemical equation below. And so I'm giving an account now. This is my own way. Everything you see there, until you get to the balanced chemical equation, until you get to the balanced chemical equation here below, okay, is what we call the mechanism. This one you see, this is a step. This is a process. This one you see, look at your screen. This is a step. It's a process. This one below, this is a step and it's a process. If you add these three together, 1, 2, 3 steps, it will give you the overall equation. This is the overall equation. This one, look at your screen. This is the overall equation. 1 plus 2 plus 3. 1 is elementary step. 1 is a process or elementary step. 2 is a process or elementary step. Essentially, in chemistry, we call them elementary steps. There are 3 of them proposed that I'm giving account how I got the overall chemical reaction. The overall chemical reaction, which is the stoichiometry, the balanced chemical equation below. Okay? And is the totality of all the events, all the elementary steps that will give account of how I've got the balanced chemical equation, the last chemical equation. And when I add up, it will give me a balanced chemical equation. And the 3, 1, 2, 3 are the molecular events that will give me the account of how I form nitrogen 4 oxide and oxygen, how I decompose the nitrogen pentoxide. And then if you get home, you can try to balance it. Let me clear the screen for you so that okay, look at the screen. When you get back, you can put 2 here. If you put 2 here, and these are the slow, put 2 here. You put 2 here. Anything on my right-hand side and also on my left, you cancel all of them. What I'm going to do is, look at it. This one is here on my left. This one is also here on my left. Anything on my left and right, I will remove it. And whatever is left, I will add up. When I add up, I will get 2 molecules of the 2 moles. I'll get 4 moles of this, and I'll get 1 of this. So this is the balanced chemical reaction. From here to this point is the mechanism of the reaction, giving account of all of how the reaction occurred. And so, as I said, this is the first one. This is a slow reaction. As soon as this and this are formed, very quickly they react, and then they react to form this, and then more of the species in the system can come together very fast to form this. And so it's an account. If you are very intelligent and you be doing reactions like this, you can propose steps like this to explain how a reaction is occurring, which is the decomposition of the nitrogen pentoxide. And if you want to relate it to your journey to Lagos, all the steps you are seeing, you have on your screen, slow, fast, fast, they are what you went through to get to Lagos. The first one, very slow, it can be from your house to UI gate. Then the second one, it be from UI gate, you enter a very good car to Ojota. Then the third one can be from Ojota to your house. You can see how we can use a trivial example like that to explain chemistry. And so you now know what is speed, what is rate, what is mechanism of a reaction. Okay, now this is equation to explain. All along, I'll be telling you stories as if I'm writing a good essay in prose. Okay, rate of a chemical reaction. You're going to write an equation for that. What happens is this. If I give you 100 naira to spend, the 100 naira is the reactant. And after some time, you bought a bottle of Coke for 50 naira. How much is left? 50. As time goes on, you bought biscuit, 20 naira. How much is left? 30. So with time, the 100 naira is like a reactant. Look at that. 100 naira is like A. And the A is decomposing to give, is reacting to give B. Okay. So 100 naira is like A I have given to you. With time, what is happening to the 100 naira as you are spending your money is decreasing. So 100 naira is the reactant. Once the reactant is being transformed, it's reacting, it goes to B, it does not disappear. It goes to B to give you product. If you buy Coke for 15 naira and you don't drink it, it will be in your pocket, it will be in your hand looking at it. What you spend your 15 naira to do is in front of you. And so the bottle of Coke is like B, but you don't have that 15 naira. What is left in A, which is the 100 naira, is 50. So with time, the reactant is decreasing. And with time, before you started spending the 100 naira, B is 0. with time, B will be increasing. What can you show for B? Your bottle of Coke, if you are here to drink it. Remember, you can't eat your cake and have it. But after, if you have eaten the cake, then your money is going there. The product, you have eaten the product. But in chemistry, the reactant is being transformed into a product. What is the implication of that? The implication of that is that with time, the reactant is decreasing and the product is increasing. Reactant A is decreasing with time. Where is it going? It's going to B, and B is increasing. And so what do we do? How do we measure the rate of such a reaction? There's what we call average rate. And that is the same thing as your speed to Lagos. I keep using the one to Lagos so that you can follow what I'm explaining. Your speed to Lagos is essentially its average speed. At a point, you are very slow. Then you run into a hold-up, which you call go slow. Okay? Your speed will go down. And then after some time, when it clears off, and then you increase your speed, and then it will go up again. And then when you put all this together, you can find the time it took you to get to Lagos, and then this distance from here to Lagos, 100 kilometers, and then you can calculate your speed. Essentially, that speed is what we call the average speed. So roughly, we can be talking of average speed, but as we go on in chemistry, we will still talk about what we call instantaneous rate when we plot a graph to find the rate of a reaction. So what did you see in 1A? Look at 1A. What are you going to see there? Average reaction rate is like your average speed. Change, look at this. Change in concentration of the reactant. Look at any time you see something like this, look at your screen. You see something like this. It means mole per dm cube. Mole per dm cube. Anytime you see something like this, mole per dm cube, look at that. Change in concentration of the reactant. And I put it there. Over the time taking. What is your change from here to Lagos? You started from 0. Then you landed in Lagos, 100 kilometers. 100 take away 0, 100. You put it where you have the reactant, 100. And then time taking for the change. And that will give you what we call average rate of reaction. Why did I call it average? It's like sometimes your speed will be down, sometimes to be up. So you put all this together. But when you plot a graph, you find out what we mean by instantaneous rate. Then look at something that is very significant here. And I want to show you. Look at this. 1A. There's a manual sign in front of this. Look at, there's a manual sign there. That the significance of that is the reactant concentration decreases with time. So as time goes on, the concentration is changing. Let's say if I give you 20 naira, no, let me take it 100 naira, and then you have spent 60 naira from it in 1 hour. What is your average speed? Or what is your average rate of spending that money? I gave you 100 naira. You already spent 60. What is remaining? 40. What have you spent? 60. The amount you have spent over the time it takes to do that, and that will give you the average rate or average speed. If instead of using the reactant A, you can decide to use the product B. Look at 1B, equation 1B. Use the product. Because what changes from the reactant, it goes to form the product. So you can talk of average rate of reaction. You can use the product, the concentration, change the concentration of the product. That is the amount of product that is formed, okay, over the time taken to form it. Remember, in the case of the reactant, is amount that you have spent over the time taken. In the case of the product will change. Sorry, the reactant will change to form the product. So it's the amount of the product that is formed that you use to do the calculation. Remember, it is what you are spending that will give you the product. So 2 ways to define the rate of a reaction, average rate. Remember, 1B, I put plus in front. That shows the significance of that plus is that the product is increasing with time. 1A, I put minus in front of change of reactant. The significance of that minus is that the reactant is decreasing with time. So take note of that. And that is how to define average rate of reaction. But as time goes on, we find out that average rate will not actually help us. And so we're going to be using something like instantaneous rate or initial rate. You will be seeing initial rate, the rate at the beginning. Because at the beginning, the reaction is very active. It's like you. When I told you that the university has offered you admission into the university, you were very happy. And so that joy, is it still like that? Now you're in the university. You just realize that you have to attend lectures. Look at this time. And again, more importantly, you have to write exam. And then you now begin to sit up. That joy of the initial news of admission will be decreasing because you need to write exam, then you need to study. No much time to be playing around. So that is how rates are also affected. The initial rate is very effective. As time goes on, it will be decreasing with time. Okay, so you can see, so you can define rate and using equation 1 or equation 2. More specifically, look at that. What are the things we look at? We can look at the color of the reactant. We can look at the color of the reactant. We can look at the concentration of the reactant. We can look at some other things that are also like the reactant. Or like we can look at viscosity. We can look at refractive index. These are the things you know very well. We can look at scopic parameters of the reactant. These are the things that can change. If the color is becoming, to you, you say this color is light, this color is thicker. As it's behaving like that, you know that more concentration is being formed. But it's becoming lighter, going towards something like looking like 7-Up. You know that, the concentration is decreasing. So this is how we can use something. If we cannot use concentration, we can use something that is equivalent to concentration. We can use the partial pressure. We can use the concentration. We can use the viscosity. We can use the refractive index. We can even use the conductivity and parameters like that. So, ladies and gentlemen, don't want to take you beyond 6 o'clock, and we are to get the screen. Okay, I should stop sharing. Okay, if you have any question to ask, raise your hand. Now meet them. Okay. Damilola, do you have any question to ask? See the class. Hello. Yeah. Do you have any question to ask?
This about the last part that you explained.
The last part?
Yes, sir.
It will be clearer by the grace of God on Monday. The last part, I was talking about average speed from here to Lagos. If you travel 100 kilometers in 2 hours, your average speed is 100 kilometers over 2 hours. And also in chemistry, at a point we were slow, sometimes we're very fast, okay? And so you just hello, to calculate your average speed, you just change in concentration over time, or the distance you travel over time. And I said distance is change in concentration. If I give you concentration of 4 naira, in chemistry, that 4 naira, we call it 4 mole per dm cube. If I give you 4 naira, 4 mole per dm cube, and spend it, you now spend 3 naira from it in 30 minutes. Your speed is 3 naira over 30 minutes. Is it clear? 3 naira over 30 minutes. 3 naira over 30 minutes. If you look at the end of, go to the platform and download this lecture note. At the end, you will see a question. You will see a question on what I've just taught you. Okay, of a reaction. How much did you start with? And it started decomposing. What is left? Okay, if you take what you started with, remove what is left, you will get what you spent, and the time that the duration of that reaction, you divide it by the time. So if I give you 100 naira and you spend 80 naira, okay, what is remaining? 20. So what do? 100, take away what is remaining? 20. What did you spend? 80. And you spend that money in 5 minutes. What is your rate of spending the money? 80 naira over 5 minutes. That is 80 moles per dm cube over time taken to spend that money. That's what you mean by time change. Concentration change over time taken. The time taken to spend the money. Again, I give you another explanation. I give you 1,000 naira in the morning when we're coming to school. By this evening, 10 hours after, it's only 10 naira that is remaining. If I ask you to find the rate of spending money, which is the rate of your reaction, 1,000, take away what is in your pocket now, 10, over 10 hours, or change the time, 10 hours to seconds. And then you will get 1,000 becomes 1,000 mole per dm cube. It has to be in concentration, okay? And your concentration should be in mole per dm cube or molarity. Divided by time. You can change the time to seconds, SI units. Is it clear? I don't know whether. Okay. Any other question? Babalola, Babalola, do you have any question? Oluwa Tayo Alabi, do you have any question? Idou, do you have any questions? Samuel.
Sir, I have a question, sir. Oluwa Tayo Alabi.
Ask.
Sir, the lecture.
What is it?
For today, on YouTube.
Sorry, go to the platform. You can download it. It's there. Okay.
Yes, sir. Thank you, sir. Thank you, sir.
Okay. By Monday, by the grace of God, by Monday, if you go through that lecture note, you will understand more. By Monday, I will make it clearer. On Monday, the lectures on Monday, I will upload it maybe on Sunday, and then you can download and read, so that before you come, you have an idea of what we want to do. Okay. Any other question? Joshua Adigun, do you have a question?
Yes, sir.
Ask.
The area of the mechanism of the reaction, that example you gave us, is not clear.
Okay, it's not clear. Okay, I will repeat it. Have you downloaded the lecture?
No, sir. I don't even know what platform you are talking about, sir.
LMS platform. We have taught them how to get to the platform.
I don't know how to get to the platform.
Okay, ask some of your classmates. If you don't know, come to school tomorrow. For us, A5. We will explain to you how to get to the platform. Okay.
Okay, sir. Thank you, sir.
Group A5 chemistry.
Okay, sir.
Okay, Solomon, Precious. Do you have any question? Solomon. Precious.
Yes, sir.
Ask.
Yes. So pertaining to the mechanism of the reaction.
Yes.
Yes. I want to ask whether the molecular events, is it based on experimental basis or will they be gotten theoretically?
You have to do experiment to confirm some of those steps. Okay. We can do that.
Okay, sir.
You work it out. You can work it out based on your experience. It's like this. If I ask you to go to Lagos and you don't know that you have to pass through Redeem camp. Can't you get to Lagos through Ijebode? You go to Caleb University.
Sir.
You go to. Do you understand? So can't you walk out another way without going through Redeem camp to get to Lagos? Can you? Okay. Shukuma, do you have any question?
I wanted to ask that is it a must can we change the time to seconds, or can we leave it in minutes?
No, change it to seconds. Okay. If you want to give it to you in minutes, we will tell you. Okay.
And that other equation of the mechanism of equation, you are doing something about seeing 2 on both sides in order to balance.
What did you do?
No, like when you were explaining it, you did something of like cancel 2 on both sides, then you will not add everything together.
What can you see on the screen? What can you tell me what you can see on the screen? Oh, stop sharing.
Is it dinitrogen pentoxide?
Can you still see? What can you see on the screen now? Can you see anything on the screen?
1A and B indicates the rate of a reaction.
Okay. What I said is the first equation. The first equation. Multiply it. Let me see. So that I can. Oh shit. Who is you? You put it on there again. I've lost it. How do we? It's network. Meeting. Okay.
Slide 20.
Yeah. Okay. Let me share. Okay.
Sir.
Share. Just a minute.
Okay.
Share. Okay. Look at that.
Yes,
can you
sir.
see?
Yes, sir.
Let me just point. Let me look at. I said put 2 here. Can you see it on the screen?
Yes, sir.
Can you see the screen?
Yes, sir, I can.
Put 2 here. Put 2 here. Did you see it?
Yes, sir.
Oh yeah, add up. Add. You have these 2, NO2. Look at this is NO2. This is NO2. How many of them do you have now? 3.
Yeah.
This is NO2. How many? Add up. How many of them?
That is 5.
5. Oh yeah, go to your left. Remove. Begin to remove. Take this one away.
Oh, that is 4.
How many? How many left?
That is 4, sir.
That is how I got this 4. Is that okay? Let's go to oxygen. How many oxygen do you have here on your right-hand side? Look at this one.
Yes, sir.
Did you see any other oxygen?
No, sir.
Oh yeah, that is how I got this one. Is it clear now?
Yeah.
Oh yeah, let's go to your left. Look at N2. Oh, this is 2 moles of N2O5. Look at your right-hand side. Did you see N2O5? How many of them did you see?
Only 2, sir.
How many on your left?
2.
That is how I got this one.
Okay.
Okay. Now let's go to NO. Look at NO here. NO on your left. There's another NO on your right. Look at it. Look at how I'm removing it. Those two will cancel themselves. Right, left. Okay, look at NO3. Look at one. And look at another one. NO3. How many did you see on your left?
Sir.
How many on your left?
2.
2. Oh yeah, cancel them. Remove it with this one.
Okay.
NO2.
Okay.
Is it clear now?
Sir.
Is it clear?
Yes, sir.
Okay, so that's how I got the balanced chemical equation. Okay, whatever is on my left and on my right, if I have 10 boys on my right and I have 5 boys on my left, I will remove the 5 on my left, remove them from the 10, and 5 boys will be remaining on my right. And that is how I was able to balance the chemical equation. Okay, so see you on, by the grace of God, next week, Monday. Have a nice weekend. Discuss. Can you play this? I stopped. Okay. So I click this. What about YouTube?